We're going to do examples, Rajul, problem number 9. And as you can see, we have a few more guidelines here than we have in the other ones. The newest guidelines are guideline number 5, combine fractions and simplify complex fractions. Guideline number 6, use difference of squares and get like denominators. And finally, remember how to factor and simplify expressions. That's guideline number 7. Now, difference of squares, just in case you forgot it, is a squared minus b squared equals a plus b times a minus b. Just as a refresher, if you had something like x squared minus 9, a equals x, b equals 3, because 3 is the square root of 9, and so that would become x plus 3 times x minus 3. Now that's really interesting and that's very good for algebra, but we're going to use this for trigonometry. And I'm going to do a couple of examples of what you could do with trigonometry to do the same exact thing. So what if I had secant squared x minus tangent squared x as an example? That would become secant of x, well, so a is secant of x, b is tangent of x, so this becomes secant of x plus tangent of x times secant of x minus tangent of x. Let's do another one. I'm going to go ahead and erase these, so if you need to take a look at them, please pause this. Well, let's take a look at another trigonometric example. I'm going to leave that algebraic example up there for you to look at. But what if I had something like 1 minus cosine squared x? And by the way, that's what we're going to need to use in this particular problem when we finally get to it. So in this case, 1 is like 1 squared. So a is going to equal 1. B is going to equal cosine of x. And so this becomes 1 plus cosine of x times 1 minus cosine of x. And again, if this isn't at all confusing for you, please kind of rewind this or pause it and try to think about this a little bit. And you can also, of course, ask me about this in class. Now let's go ahead and go back to problem number 9, now that we've had this refresher on difference of squares and how you might use it for trigonometric functions. So let's take a look at problem number 9. So right away, we see, using guideline number 1, that's this one right here, that we have an even identity. That even identity is cosine of negative y. So cosine of negative y becomes cosine of y. Let's go ahead and make that simplification before we do anything else. So this becomes sine squared of y over 1 minus cosine of y minus 1. Now, remember that we love Pythagorean identities. That's this guideline right here. Pythagorean identities are your best friend. So I'm looking at this Pythagorean, or this sine squared of y right here, and I'm saying to myself, I know that turns into 1 minus cosine squared y. Let's go ahead and write that up here. Sine squared y becomes 1 minus cosine squared y. And using difference of squares, I know that this turns into 1 plus cosine of y times 1 minus cosine of y. And as you can see from our problem, I've got a 1 minus cosine y right there that I can eliminate if I were to make that substitution. So that's exactly what we're going to do. So let's go ahead and do that now. So this becomes 1 minus cosine squared y over 1 minus cosine y minus 1. Now we're going to factor that, and we're going to get 1 plus cosine y. Let's go ahead and give myself a little bit more room. Times 1 minus cosine y over 1 minus cosine y minus 1. And as we can see, we can just cancel that out very easily. This is going to become 1 plus cosine y minus 1. As we can see, the ones are going to cancel out. And you're left with just cosine of y. So that means that this expression that we started out that didn't look at all like cosine y simplifies to cosine y. Let's make sure that we got that right by checking Desmos. Okay, so on Desmos, I've got my initial expression and then I've got my simplification. My initial expression is in red here. And now let's see if the blue line covers over the red line, or the blue graph, I'm sorry, covers over the red graph. And it does. And that means that we got problem number 9 right.